Close your eyes. Imagine you are standing on the shore of a cosmic ocean. Each wave that laps at your feet is not water, but time itself. Tonight we have a vessel capable of sailing that ocean, a machine that can look back to the very beginning. It is the James Webb Space Telescope, and it has seen something in the dawn of creation, something impossible, something that, according to our best understanding of the universe, simply should not exist. Join me as we travel to the edge of time to witness a discovery that is rewriting the story of everything. For decades, our story of the cosmos had a clear beginning. There was the Big Bang, an infinitely hot, dense point that expanded. For 380,000 years, the universe was an opaque fog. Then came the cosmic dark ages, a vast expanse of time when there were no stars, only cooling gas and whispers of gravity. Our models predicted a slow, patient process. Over hundreds of millions of years, gravity would gently pull matter together, forming the first small, fragile stars. These stars would then cluster into tiny, disorganized galaxies. We expected the early universe to be a nursery of cosmic infants. That was the story we were so sure we would confirm. Our vessel for this journey is a modern marvel. Picture a honeycomb of 18 golden hexagons, polished to a perfect mirror. This is Webb's eye, designed not just to see, but to see in infrared light. This is crucial because the light from the farthest galaxies has been traveling for so long. The expansion of the universe itself has stretched it, shifting it from visible light into the infrared spectrum. Webb is built to see the invisible echoes of creation. This magnificent eye is protected by a sun shield the size of a tennis court, made of 5 layers of a material as thin as a human hair. It keeps the telescope in a perpetual, deep shadow, chilling it to temperatures colder than any natural place in our solar system. This extreme cold is necessary to detect the faint, ancient heat of the first galaxies. It is an instrument of profound sensitivity, waiting in the silent darkness. It doesn't orbit the Earth. Instead, it hovers 1,000,000 miles away at a special point of gravitational balance called Lagrange point 2. Here, it can keep the sun, Earth, and Moon all behind it, ensuring its view of the deep cosmos is forever unobstructed. It is a lonely sentinel, our farthest outpost dedicated purely to looking back in time. When Webb began sending its first images, the world held its breath, and what we saw was more beautiful than we could have imagined. Deep fields, glittering with thousands of galaxies, each one a spiral of light, an island of stars. But as scientists looked closer at the faintest, reddest specks in these images, a sense of confusion began to grow alongside the awe. These specks were the galaxies of the early universe, the ones we expected to be small, clumpy, and chaotic. But they weren't. Many of them were shockingly large. They were bright. Some even showed signs of complex structures, like spiral arms or galactic bars, features that should take billions of years to develop. Imagine planting an acorn and returning the next day to find not a sapling, but a towering, ancient oak tree. This is the feeling that washed over the astronomical community. Webb was finding galaxies that existed just 300 to 400 million years after the Big Bang. Yet they looked impossibly mature. They were cosmic prodigies. One such galaxy, named Glass Z13, was among the first to cause a stir. It was a contender for the oldest galaxy ever seen. But more than its age, its brightness was the puzzle. To be that bright, it had to be surprisingly massive, containing perhaps 1 billion times the mass of our sun in stars. How could so many stars form so quickly? Our standard model of cosmology is built on a specific timeline. It gives a clear budget for how much time is needed for matter to gather. Gravity is powerful, but it is not instantaneous. The universe needed time for the primordial hydrogen and helium gas to cool, collapse into clouds, and ignite into the first stars. This process, we thought, was a slow one. These early galaxies seem to have bypassed that entire process. They appear on the cosmic stage fully formed, as if they skipped their childhood and adolescence. The universe's timeline, the one we had carefully constructed over decades of observation, suddenly seemed far too short to account for what we were seeing. So, what does this mean? Are our fundamental theories of the universe wrong? Not necessarily. It more likely means they are incomplete. The discovery of these impossible galaxies is not an end, but the beginning of a new chapter, forcing us to consider new and exciting possibilities about how it all began. Let's explore the first possibility. Perhaps star formation in the early universe was wildly different and far more efficient than it is today. The conditions were more extreme. The gas was denser, pure, containing only the elements forged in the Big Bang itself. Maybe this environment was a perfect stellar incubator. This leads to the idea of a lost generation of stars, known as population 3 stars. These are the hypothetical first stars, and they would have been true monsters. They could have been hundreds or even thousands of times more massive than our sun. They would have burned incredibly hot and bright, living for only a few million years before exploding. These catastrophic explosions would have been the universe's first forges. They would have seeded the surrounding gas with the first heavy elements: carbon, oxygen, iron, the very building blocks of planets and of us. This rapid seeding could have jump-started the formation of the next generation of stars, accelerating the entire process of galaxy building. So, Webb might not be seeing galaxies that are too old, but rather galaxies that are powered by stars far more extreme than any that exist today. They are bright, not because they have more stars, but because their stars are 1,000 times more luminous than our own sun. It's a tantalizing theory. Now let's drift towards a deeper mystery, one that lies beneath the visible matter. Let's consider dark matter. We believe that every galaxy, including our own, is built on a scaffold of this invisible substance. Its gravity is what pulled the first gas together, creating the seeds from which galaxies would grow. Our models assume that dark matter is cold, meaning it moves slowly and clumps together easily. This slow clumping is a key reason why we thought the first galaxies would be small. But what if dark matter isn't so simple? What if its properties were different in the early universe? Perhaps dark matter halos, the invisible skeletons of galaxies, formed much, much faster than we predict. If these gravitational wells appeared sooner and were more massive, they would have acted like cosmic supermagnets, pulling in enormous amounts of gas at an incredible rate, providing the fuel for these shockingly large, early galaxies. This doesn't break the Big Bang theory, but it would revolutionize our understanding of its largest, most mysterious component. Finding evidence for this would be as profound as the discovery of dark matter itself. It would mean the unseen universe is even more dynamic than we ever guessed. Another idea is that these early galaxies aren't as massive as they appear. Perhaps we are being fooled by what lies within them. Some theories suggest that the bright centers of these galaxies aren't just stars, but are instead powered by ravenous, supermassive black holes. If a massive black hole, a direct collapse black hole, formed very early, it would begin to feed on the surrounding gas. This process would release an enormous amount of energy, creating a quasar that could outshine billions of stars. What we think is a huge galaxy might, in fact, be a much smaller one with a monstrous engine at its heart. But this, too, presents a puzzle. How do you form a supermassive black hole so quickly? It's another chicken and the egg problem. Did the galaxy form the black hole, or did the black hole form the galaxy? Webb's observations are pushing these questions to the forefront of cosmology. Now, let us consider the most profound, the most reality-bending possibility. What if our entire model of the beginning needs a new preface? The standard Big Bang model suggests everything began from a single point, but some theories, like cosmic inflation, suggest our Big Bang was not the only one. Imagine a universe that has cycles of expansion and contraction. Perhaps the universe that existed before ours did not completely disappear. Perhaps it bounced, leaving behind seeds of structure, tiny fluctuations in density that survived the transition from one cosmic era to the next. If this were true, the universe would not have started from a perfectly smooth state. It would have had a head start. These pre-existing seeds of gravity would have given galaxy formation a massive, immediate boost, allowing structures to grow far faster than they could from scratch. Webb, in this scenario, would not be looking at the first things to ever exist, but at the first things to exist in our chapter of the cosmos. It would be a hint that time and the universe itself may be far older and stranger than our current story allows. This is, of course, highly speculative. But the purpose of a tool like the Webb telescope is to push us into these uncomfortable, wonderful new territories of thought. It is designed to find things that we cannot easily explain, because that is how science moves forward. Every one of these potential explanations is a universe of discovery in itself. Whether it's monstrous first stars, a dynamic and changing dark matter, or echoes from a previous cosmos, the answer will reshape our place in the universe. The confusion we feel is the feeling of a new door opening. And isn't that a comforting thought? The idea that the universe is not a solved puzzle, but a constantly unfolding story. A story that is more grand, more surprising, and more intricate than we had the imagination to write on our own. Webb is simply the pen that allows the universe to write its own history for us. As we drift now, surrounded by these silent, impossible galaxies, let the mystery soothe you. The pressure to have all the answers fades away, replaced by the simple, peaceful wonder of the question. We are a part of a cosmos that is still revealing itself, still surprising its inhabitants, even after 13.8 billion years. These ancient lights are our cosmic ancestors. The elements forged in their cores now flow through our veins. Their story is our story, and learning that their story began earlier and more spectacularly than we knew only adds to the majesty of our own existence. We are the legacy of an unexpectedly brilliant dawn. So here we are, at the end of our journey for tonight. We have traveled with photons, 13.5 billion years old. We have stood before galaxies that break our neat and tidy models of the universe. The James Webb Space Telescope was built to find the first galaxies, and it succeeded. But it found that the universe was in a greater hurry than we ever thought possible. It shows us that nature's creativity will always outpace our own. The story of our cosmos is still being written, and we are lucky enough to be here to read the latest page. This isn't a failure of our science. It is its greatest triumph, the discovery of a mystery more profound than the one we set out to solve. Thank you for joining me on this voyage through space and time. If this cosmic puzzle has brought you peace, please consider subscribing for more journeys into the unknown. Like this video to share the wonder, and let me know in the comments below. What do you think these ancient galaxies are trying to tell us about our universe? For now, let the mystery cradle you. Let the ancient light guide you to a peaceful rest. Good night.